I welcome all to this seminar on structural repairs for mass housing and infra projects. For the beginning of the event, I request everybody to stand up for the national anthem.
Lokesh, make it full screen.
Now I request Mr. Ravindra Ringshia to give the welcome address. Mr. Ravindra has 30 years experience in executing, planning and designing various projects of civil projects. He has completed his BE in construction engineering in 1990 from University of Mumbai with distinction. He returned to India in 1992 after his study in USA of Masters in Construction Management and Structurals to join his family-owned construction business. Mr. Ravindra has successfully executed many projects which are World Bank aided infrastructure projects, including treatment and pumping of sewerage plants, pile foundation works, micro piling, stone columns, anchoring, and precast piling. He has been engaged in the construction of residential buildings up to 40-story high, structural repairs and renovations, pipeline projects, infrastructure projects as consultant for metro projects, smart city, the first smart city in India at Kandla, and also at Faridabad. He has been engaged in the Goregaon Mulund Link Road, which is India's one of the biggest diameter tunnel project. Mr. Ravindra is a very active member of ASCE, and he has worked in various committees of ASCE earlier. He is married to Deepakshi and his two daughters, Akansha and Anushka, and the son Aryan. With this, I request Mr. Ravindran to take forward with his remarks.
Am I audible to all?
Yeah.
Yes, yes.
Just a minute, Mr. Ravindra. Mr. Lokesh, make that full screen. Mr. Lokesh, can you hear me? Make the PPT full screen.
Go into slideshow.
Okay, ठीक है चलो.
Yeah, go to slideshow.
Sir, is it now on full screen?
No.
Not yet.
No, go to slideshow. You have to go click on the slideshow on the top. Options you have. Yeah. Then go from present slide. From current slide. Yeah.
So this is the issue. It's not coming on full screen.
ठीक है, okay. View. Go to the view option on the top. Slide show के बाजू में.
Okay, not a problem. We'll carry on.
Yeah, not a problem.
Yeah, let it be. Lokesh, let it be. Don't worry. It's an IT problem, not a civil engineering problem. Yeah, fine. So It's my pleasure to welcome again our chief guest, Mr. R.N. Gupta, President BAI. Our today expert speaker, Dr. Ehsani, Centennial Professor Emeritus of Civil Engineering, University of Arizona, USA, and President of QuakeWrap Inc. And Dr. Ilyas, Director Region 10, ASC from UAE, Dr. Kamal, Governor Region 10, ASC from Sri Lanka, Mr. Deepak from High Speed Rail Corporation, Mr. Rajendra Pawar, Past Secretary WRD Maharashtra, Mr. Tilak Raj Kapoor, Past Secretary Water Resource Department MP, Mr. Carlos from Mexico, Mr. Yashpal Mehta, Delhi Metro Rail Corporation, dignitaries from Water Resource Department from Maharashtra and MP, dignitaries from Sardar Sarovar Narmada Nigam, and dignitaries from Penn India and all over the world, students and my dear friends. A warm good evening to all of you, and to few a warm good morning. It gives me immense pleasure to welcome one and all to this international webinar on structural repair, mass housing and infrastructure projects, organized by American Society of Civil Engineers, India Section Western Region, along with Builder Association of India and India chapter of American Concrete Institute as a co-organizer. The entire board and myself are honored to have you all today. I especially welcome our new members who have joined our membership of ASC, Mr. Yashpal Mehta, Mr. Rajendra Pawar, and Mr. Raipat. They are the youngest member of ASC, and I look forward for their continued support to ASC ISWR. It's auspicious day today. It starts off festival season with Navratri. Navratri is a Hindu festival that spends 9 nights and is celebrated every year in autumn. Goddess Durga is worshipped. This would be followed by Dasera on 16th of October and Diwali on 4th of November. Diwali is the festival of light and is one of the major festivals of Hindus, Jains, Sikhs, and some Buddhists. This festival would be followed by Thanksgivings and Christmas globally. I wish you all a happy festive season ahead. American Society of Civil Engineers is the world's largest and oldest society of civil engineers. The society, with its world head office in Eastern Virginia, USA, would be celebrating its 170th anniversary in the year 2023. ASC is well known for its many contributions to the society. One such very important contribution is making US report card. Other contributions are laying down of codes and standards, conducting regular events. ASC is first to reach out and give assistance during many natural disasters globally. ASC is constantly referred by US President and other authorities for formulating and guiding policies regarding civil engineering. Due to geographical size of India, a need of Western Region India presentation was felt, and during 1999, Western Region Group of ASC was formed, with me as one of the 20 founder members. The main focus of ASC ISWR is same as that of ASC, that is to contribute to the improvement of the image of civil engineers and make their contribution to the society more effective. Keeping this in mind, and also to have more effective contribution during my installation as a president of Western Region, India section for the second tenure, the board accepted my proposal. This webinar is one more such event. ACI and other local associations. As I always say, let's start. During my introduction also, I said, let's start. Let's start with the small steps, one at a time, to make a difference. Let us join hands and keep more such events jointly for the betterment of society in general. Builder Association of India is a body of all infrastructure development and real estate development in countries since 1941. pre-independence. Presently, they have more than around 20,000 business houses as their direct members, spreading over 200 centers in the country. Their members are mostly involved in construction of infrastructure projects such as national highways, ports, airports, public building, mass housing, etc. India chapter of ACI was established on 26 December 1979 by a few enthusiastic concrete technologists to work under the guidance of ACI USA for the development and advancement of good practice of concrete technology in India. Today, all Indian members of chapter consist around 2,000 concrete professionals and organizers, including consulting engineers, concrete practitioners, academicians, research consultants, civil engineers, material scientists, students, etc. I am also one of the institution member of ACI, long back since 1995 or so. A proud member of ACI and ACI both. The driving factor behind ACI activity is their sole motto, that is progress through knowledge. ACI chapter has distinguished performance in organizing seminars, symposiums, technical lectures, meetings, and workshops. As I always say that during this pandemic, I had traveled entire globe, but without stepping out of my house. That's the advantage of having a positive side of this pandemic. But as a civil engineer, especially field engineers, we need to be at forefront. We, the civil engineers, just cannot get the project executed sitting inside our home. We need to be out in field, risking not only our life, but life of our entire family. As a civil engineer today, we need to work safely, not only in work atmosphere, but also against safety, against virus, to keep our nation move forward and for the betterment of the society as a whole. So as I always say, we, the civil engineers, too are our frontline warriors. I know we all are eagerly waiting to hear our expert speaker. With a very warm welcome to once again, I request MC Mr. Raipat to carry program forward. Chandrakant Pratap Singh Raipat is a civil engineer of 1986 batch from Birla Institute of Technology. He owns multiple business and is a very active BI member. And he has also become a recent member of ASCE. So with this, I once again welcome everybody and request Mr. Raipat to take the program forward. Welcome.
Thank you, Mr. Ravindra, for the excellent welcome remark to all of us and all the guests from abroad and around the world. Now is the auspicious time for the introduction of our own President of Builder Association of India, Mr. R.N. Gupta. And the privilege of introducing him goes to Mr. Mahendra Rizwani, who is the second generation member of Builder Association of India. Rather, I knew his father also, and now I'm having interaction with him also. And he is heading our Mumbai chapter, Mumbai center. Am I correct, Mahendraji?
Yes, sir. Yes.
Yeah, please go ahead with the introduction.
Thank you, Chandrakant Raipat. Shri R.N. Gupta, born in the year 1949, he did his MSc in mathematics from University of Delhi. He is the founder and promoter of Ram Civil India Construction Private Limited, formerly known as Rama Construction Company, an ISO 9008-2008 certified company. His firm is EPC and Super Class 1A contractor of CPWD for over last 5 decades and addresses critical needs in key sector of construction of residential, commercial and infrastructure projects with all allied services and complete solutions. His firm, with its head office in New Delhi, has over 12 regional offices across the country and more than 1,500 employees. His firm is executing the works with CPWD, NBCC India Limited, Airport Authority of India, HHCC India Limited, MSc under Ministry of Micro, Small, Medium Enterprises, and PWD Delhi. His firm has been awarded several times for his excellent performance in completing the projects before stipulated time scheduled, which includes the 5-star rated GIRA Award received in the year 2014 from the Honorable President of India for the CAG project in Jaipur. His company joined Builder Association of India, Delhi Center as pattern member in the year 2004. He was elected unanimously to the post of Vice President from BI North Zone from the year 1617 and 1718. He has served as the Honorary Treasurer of BI Delhi Center for 2008-2010 and Chairman of Delhi Center from 2014 to 16. During his tenure as Vice President, he has opened 9 centers in northern region. He has enrolled more than 200 pattern members in the association with other senior members of Delhi Center. He has been awarded Vice President of the Year for 2017-18 by Builder Association of India. He is involved in a lot of professional, social and cultural activities. He is a permanent member of Indian Building Congress and he has been Vice President for 3 years, that is 19, 20 and 21. He is a pattern member of Maharaja Agha Sen Hospital, Punjab Bagh, Delhi, Dwarka Project Samiti and Sri Agha Sen International Hospital, Rohini. He is a trustee and chairman for construction of Agarwal Welfare Society, Ashok Vihar, Delhi, which runs public school, hospitals and dharamshala in the name of Maharaja Agha Sen in Ashok Vihar, Delhi. He is also a lifetime member and has contributed for establishment of Patanjali Yogpith Trust in Haridwar, Uttarakhand. He is the secretary and executive member for Shri Krishna Leela Samiti, a unit of Agarwal Mahasamaj, an organization established for social welfare and Krishna consciousness. He is a member of Ram Krishna Mandir, Ashok Vihar, Delhi. He is a pattern member of Kamdev Cows Hospital, Balor, Bahadurgarh, Haryana. He is an active member of Akhil Bharatiya Agarwal Sangathan, Akhil Bharatiya Agarwal Summellan and Seema Jagran Manch, Delhi. Thank you. I now welcome Shri R.N. Gupta with a bouquet of flowers virtually.
Am I audible to all?
Yes, sir.
Thank you. I am audible to all?
Yes, sir. Yes, sir.
Namaskar to all. Good evening, friends, delegates, and welcome to all. I thank organizing committee of today's webinar, Shri Ravindra J. Ringsia, President, American Society of Civil Engineers, India Section, Western Region. Shri Sunny Solekar, President, India Chapter of American Concrete Institute. Our Shri Anand Gupta ji, Chairperson of BI Housing and RERA Committee, and also the Managing Committee of the today's webinar for inviting me as a chief guest for webinar on structural repair of housing and infra projects. I am honored to be among us as a President of Builder Association of India, known as BI, one of the biggest and largest trade body relating to the construction industry in India. BI is now has more than 200 business entities and its member in more than 200 centers. BI is only recognized by the state government, but also organized by the central government also. This is evident from the fact that the BI is invited for reviews by the government on policies issues. Construction is an important constituent of every sector in economy. Construction is the second largest employer after agriculture. Just for its size and relevance to the economy, the construction industry is an unorganized sector. It has a backward linkage with about 120 industries such as cement, steel, tiles, sanitary wares, pipes, etc. Whereas forward a linkage with a host of industries such as paint, furnishing, housing, finance, electrical, etc. A change in the level of industry output only affect the GDP, but also the fortune of the host of industries which it has been linkage. Thus, during the period of economic stagnance, the housing industry is an encouragement to revive the growth in the other sections of the economy. Friends, as you know, that the repair job involving 3 distinct stages at different levels. In the first stage, documentation of damage, type of damage, and its extent, forecasting the repair structure and recommendation on repair methodology. Second requires preparation of detailed drawing, sketches, execution guidelines, and notes, material and work specification, and tender documents. The third stage is actual execution of the repair. For specialized agencies and jobs, experts in this repair field and resources in terms of tool and plants should be engaged. The engineer in charge should have a good understanding of the procedures and given tentative supervisions. To find out the effectiveness of the repair, various tests before and after the repair have been conducted. Building maintenance is work undertaking to keep, restore, and improve every facility to every part of building. Its services, including horticulture operations, to a currently acceptable standard and sustain the utility and value of the faculty. But now, most engineers and familiar with the original concept of repair and retrofit of structure with fiber reinforcement polymer FRP products that the introduced more than 3 decades ago. In that technique known as wet layup, fabrics of glass or carbon as saturated with the epoxy, and they are bonded to the surface of the structure. By the next day, the material becomes 2-3 times stronger than the steel. The material are lightweight and they do not corrode, thus providing a lasting repair, offer unique solutions for both strengthening of building and bridges and repair of corrosion damaged structure. I am grateful to learn that our eminent speaker, Dr. Ehsani, credential professor emeritus, civil engineering, University of Arizona, USA, and president of Messrs. QuakeWrap, Inc., USA, for his presentation in which he will take the participants through today's topic and some cases studies which will include a review of the wet layup system, pile-medic FRP laminates for repair of concrete, timber and steel piles and columns, sandwich construction FRP, internal and external repair of the pipes. I am very happy to join specialized type of program, keeping me as a chief guest. I hope seminar will bring the desired result as expected by the organizer, and I wish the seminar all the success. Special thanks to Dr. Anand Gupta ji, Chairperson, Housing and RERA Committee. With this, I conclude my speech and wish you all the best. Stay safe, stay healthy. Jai Hind. Thanks.
Many thanks to our President, Mr. Gupta, for the excellent and encouraging words. Now is the time for introduction of Dr. Ehsani, who is the expert speaker for today. For his introduction, I request Mr. Sunny Surlakar, who is the president of Indian chapter of American Concrete Institute, and who is also the head of the technical services of SS Buildcon Private Limited. I request Mr. Sunny to take the honors, please.
Thank you, Raipat sir. Today it is, I would say today it is my privilege and honor to be introducing a fellow alumni from University of Michigan. So Dr. Ehsani, he received his bachelor's, MS and PhD from the University of Michigan. And after that, he joined the Department of Civil Engineering at the University of Arizona in 1982. He's a pioneer in the field of repair and retrofit of civil structures, especially with fiber reinforced polymers. That is, we commonly refer to as CFRP or CFRP today, more done with carbon fibers. He has been doing this for a long time, since almost the 1980s, and has published a lot of his findings in numerous professional journals such as the ACI, in ASC, Earthquake Spectra, etc. He's a fellow of the American Society of Civil Engineers and of the American Concrete Institute as well. He has served as a president of the Structural Engineers Association of Arizona and is a registered professional engineer in 20 states. He has been featured on major media such as CNN, National Public Radio, the History Channel, Engineering News Records, and especially for his expertise in the strengthening of structures. He has invented numerous FRP related systems and has received the 2014 Arizona Technology Leader of the Year award. In 2010, Dr. Ehsani left the University of Arizona as a professor emeritus and is since devoting his full attention to QuakeWrap Inc., a company that he founded in 1994. So this company offers turnkey design build solutions to its international clients and has got numerous systems for numerous systems to address structural distress and how to get or how to strengthen structures once again. In September 2014, QuakeWrap was inducted into the US Congressional Records as a small business that is grown by being a leader in state-of-the-art technology. So with that, I would request firstly to welcome Dr. Ehsani with a bouquet of flowers, and post that I would request Dr. Ehsani to please deliver his talk for today. Over to you, Dr. Ehsani. Thank you very much.
Thank you, Mr. Shri, and thank you so much. It's great to be with you. Thanks to all of the distinguished guests, and I'm happy to participate in your seminar today. Let me start, I think, sharing my screen. So hopefully everyone can see my screen now.
Yes, sir.
All right, very good. Well, again, thank you. So I know I have a limited time, so let me just jump into the presentation and get going with this. There we go. Okay, so in my talk today, I'll start with a little bit of introduction about FRP and how these materials from an engineering sense work. And then this is really the result of about nearly 4 decades of my work. So to summarize it in 30 minutes, I hope you can appreciate it that I'm not going to be able to cover everything in depth, but I'll just give you a flavor of some of the things. I'll basically talk some about, beams and slabs and column strengthening, and towards the end, get some about, strengthening of some new products that we have developed for marine infrastructure or steel columns and so on, and then sandwich construction. So this whole thing really got started in the 80s when I was looking at, in the beginning of my career, looking at some new solutions for the infrastructure repair, because as you know, we have most of the problem is with the corrosion of steel. So we were looking for something, a non-metallic solution, and that's why we started looking at carbon or glass FRP, and I'll explain these to you in more detail. But at the time, carbon was being primarily used for the military application, so it was really expensive and it didn't make sense for use in construction industry. But for those of you who are a little bit more senior like myself, age-wise in the audience, you can recall that at the end of 80s, there was the end of the Cold War, and so the collapse of the Berlin Wall, and as a result, the military's need for these materials dropped, and consequently, the price of them went down. About the same time, there was this major earthquake in 1989, Loma Prieta earthquake in California, where many of the columns in these bridges and buildings, they failed because they did have enough longitudinal steel, but they did not have enough ties to confine these columns. So everything was kind of falling into place. And so at that time, we started developing this company, QuakeWrap. In fact, the name QuakeWrap came from that, looking at that first application, which was wrapping these fibers of carbon around the column to make it earthquake resistant. So that's how we got the beginning or the start of our company. These materials, FRP stands for fiber reinforced polymer. And if we look at this, we have in a way similar to how we make reinforced concrete structures. So we have a matrix, which is shown here in red. This matrix can be either, it is the polymer portion of it, so it can be either epoxy or vinyl ester or polyester. We usually use epoxies. And then it is being reinforced with these carbons that are shown in dots here. Now, the one thing which is very different about FRP compared to other materials is that unlike other engineering materials that are isotropic, these FRP products, they have anisotropic. So their strength comes from the orientation of the fiber. And so that's really something to keep in mind, that it is the fiber that gives the strength. And that can be a very useful attribute of these products. In terms of their strength, unlike, we are familiar mostly with steel that goes through a yield plateau, and you have maintain that strength. FRP products are all act linearly elastic to failure. So here we have carbon FRP or glass FRP, and as you see, both of their breaking strength is higher than steel, but they work linearly elastic to failure. So this is something to keep in mind. But as I'll show you some of these applications, really keep in mind that these are just like any type of tension reinforcement that you use, except that they don't corrode. So that's the main advantage of it. So again, some of the, I'm not sure why this is somebody else, if somebody else is controlling this, I hope they are not, I can control the thing on my own here. So we have, the advantages are listed here. We have high tensile strength, about 3 to 5 times that of steel, lightweight, if you're strengthening a building, you don't need any, usually any foundation adjustment. They are, as I said, they're corrosion resistant, excellent chemical protection, and they are waterproof, of course, and construction goes really fast, and they are versatile, that they can be applied to any type of cross section, taking that shape. These are some of our particular own product attributes, that they are safe for the environment. So we have no VOC or volatile organic compounds. They're 100% solid. And our products are also odorless, and we have the certification for repair of potable water pipes and tanks. So in general, these FRP solutions, they offer a low-cost alternative, which is a good return on your investment for many of these projects. So I thought, as an example, if you really to grasp this concept, let's say, for example, of course, there have been codes developed recently. The ACI Committee 440 has now documents that help us, with the design of these. But let's just say, if you are looking at a typical concrete wall, for example, which has, let's say you have some number 7 rebar. Number 7 is basically about 22 millimeter in diameter at a spacing, at a certain spacing. So, and that number 7 rebar, I'm not sure. Yeah, that number 7 rebar has a force of about 36,000 pounds. And if you put a layer of this carbon fabric on the surface of the same wall, this particular fabric has all of the carbon fibers in the orientation of that green arrow. So if you took 1 inch or 25 millimeter of this and test it, you see that it breaks at about 6,000 pounds every 1 inch. So really the comparison of these is that 6 inch of this fabric gives you the same force as one of those reinforcing bars. So basically, if you cover your wall with this layer of this carbon fabric, it is the same strength as if you were putting these number 7 rebars in your structure. And as you can appreciate, of course, this is very thin and it goes on very easily. So construction is really easy. And then, of course, you have an impervious layer on top of your structure that prevents it from corrosion. As I mentioned, the design of these is nowadays, controlled in the US and a lot of other countries as well by this ACI Committee 440, that this is the second edition of the design guidelines that was published a few years ago. I thought with this video, it might give you a good idea of how the original system that we developed work. Here I have a series of bricks put on a table. They are not even connected or bonded together, but I don't know what, yeah, let's just hope. Let's show this video. Hopefully nobody is touching this, so the video will play. So we can take this carbon fabric, which is the reinforcement. You see, you can cut it with scissors easily. Then we mix this epoxy paste material. I'm not sure why this is doing it. Okay, I guess we won't show you the video. Something is technically going wrong. But, these FRP products are best for tension reinforcement. And again, realize that in concrete structures, shear is also resisted as diagonal tension. So they work with that. They're excellent for confinement, water and chemical resistant barrier. Remember that for corrosion to take place, you need oxygen present. And if you wrap your structure with a layer of FRP that does not allow oxygen or moisture to penetrate, this definitely would help stop the flow of oxygen, and it would bring the corrosion to a very small or low rate. What they are not so good at is for compression reinforcement, and we usually ignore their contribution to compression. I noticed that Mr. Gupta is from the Building Association of India, so I had to put in this slide to tell you that when how we deliver these systems is somewhat unique, because originally when I had come up with these concepts many years ago, construction companies and contractors didn't want to get involved with this thing. So we ended up in QuakeWrap, which is an engineering company and develops materials and sells the materials and does the design of those. Then we have a construction company, FRP Construction, that does the installation. So we either work together as a turnkey solution this way, or we work with other contractors and we can train them to do the installation of this product. And sometimes, our company and other contractors, we team up as a subcontractor arrangement. So there are various ways of delivering these systems. And, in this slide, because of the shortage of time, I thought I would, at least in one slide, just tell you that all the different type of applications these materials can be used in, and hopefully some of them I'll get to cover in more detail. So, the first building you see on the upper left, this was a building that they wanted. It's an 8-story building in Miami, Florida, and they wanted to build 2 more floors on top of that. So the columns in the lower 8 floors, there were 180 columns. We strengthened those columns so they can carry the weight of the additional floors. The pipe that you see here is a penstock for a hydroelectric project in Costa Rica that they had built. 1.75 kilometer of a 2.1 meter diameter pipe. When they tried to, the pipe was built on site. When they tried to build this or turn it on, they realized that there are millions of holes in this pipe and it was leaking. So we fixed that in 3 weeks and received a couple of international awards for that project. That bridge that you see, sometimes, even construction errors could be a good candidate for these repairs. This was a brand new bridge that was being built in New Mexico. and there were two similar bridges, one going eastbound and one going westbound. They realized that in one of those bridges, they had left half of the steel from the deck. One half of the total steel was forgotten to be put in place. So instead of tearing the bridge down, we retrofitted that bridge, and now that has been in service for about 15 years. And if you drive over it, you cannot tell with the difference between this one and the one next to it. The next project is in a mining industry, a settling tank in Mexico project where they hold sulfuric acid in these mines, and it's a very corrosive environment, and we can strengthen by those tanks by lining them. Projects, for example, for United Nations a few years ago when they built a new headquarters in Beirut, Lebanon, we provided blast retrofit for that building before they moved in, so that's another application. Many projects on historic buildings and preservation. In India, you have a lot of historic buildings, with your rich culture. These types of solutions are ideal because they can be used without changing the historic nature of those structures. As here you see one, the Los Angeles County Museum of Natural History. That other 14-story building in the middle, it was damaged in an earthquake in Alaska. And because of the high cost of repair, it was left abandoned for 20 years. But with these solutions, it was fixed and again received an international award for that. We make pipes out of these products of different shapes and sizes. These pipes can be made very close to the job site. That's the main advantage. So you don't have to pay a lot for transporting them. And in this project that you see in Australia, our office in Australia is repairing a culvert under a roadway with pipes which were built in our office in Brisbane. On industrial facilities like this chimney that suffer from corrosion, this was in Kazakhstan back some 15 years ago. We were repairing the upper portion of the chimney. Again, down below, this will be a world record setting project that we just getting embarked on. It is a 5.1 meter diameter tunnel in Detroit, and the tunnel is damaged. We will be making pipes that are about 4.95 meter in diameter, again, very close to the job site, and repair that pipe with it. Utility poles are another thing that we do. The one next to that is penstocks. I was involved with the project for NIPCO, the Northeastern Power Company in India, that they had some issues with one of the penstocks, steel penstocks. This is a sample of such projects that we have done in US. This happened to be a 90-year-old riveted penstock that we were repairing. Piles in underwater. This one project that we have shown here is for the Nigerian Petroleum Corporation. We repaired about 90 or so piles for them. And then seawalls, which is another part of the infrastructure that in coastal areas, they get damaged by corrosion. So these are just to really, you get a flavor of the different applications that you can do with these products, and also as well as how many different corners of the world that we have implemented these solutions. If anybody is touching, controlling these, please don't do that. I can control this from here myself. Yes. So let me just look at the beams as as the mechanism of it from an engineering point of view. Typically you have some tension that is in a concrete beam. The tension comes from steel, and the concrete provides a compression. You get a moment capacity. If you have lost some of that because of corrosion of steel, by adding these layers of FRP on the bottom of your beam, for example, you get this additional tension force and the new increased moment. And so some examples of this, for example, keep in mind that in the flexural direction, remember these FRP products are anisotropic. So you have to be careful that what orientation the fiber is placed. So the fabric that you see on the bottom of the beam going along the span. The fibers are in the direction of the span. And then for shear reinforcement, we have the fabrics or the fibers going in the, in the vertical direction. Here was a case that we had done some, more than 20, 25 years ago. We were doing this for a nuclear power plant where the, because of the, corrosion on the roof of the structure, the beams were very severely corroded. So they sent some of these beams for us to evaluate. And as you can see, the bottom of these beams was curved. So it was difficult to apply, steel to them, for example, to strengthen them by steel. So here we are putting some of that glass fabric saturated with epoxy. As you can see, it can be put on the bottom of these and it takes the shape of the curve. Then we can also provide the shear reinforcement. And as you see how it can just conform to the shape, it goes fairly easily. Then we tested one of these and you can see that how the gray graph shows the unretrofitted or the original construction. The red one shows after strengthening. As you can notice that how this is so much stronger than the conventional or unretrofitted beam. We had increased the strength of this beam by about 2 times with this relatively fast system. When you do, in these projects, there's also, you have to have some quality control. So one of the things is that you can keep track of the lot number for all of the products that are being used. Then another thing is adhesion test that according to the ACI code, we must have a minimum 200 PSI adhesion. So the way this is done is you glue or bond these pucks to the surface of the structure, and then we core around this and pull it, and and you see oftentimes we get a lot more than 200 PSI, but that 200 PSI is the minimum requirement. We also make witness panels of these samples, just like in concrete, you take cylinders for testing. We make these flat panels and test them later on in the laboratory for tensile strength of these. Our products are also approved by.
Can you please make this fellow who's making these changes? Can you take him out from the meeting?
Yes, please. Yeah, I would appreciate it. Yeah.
Please, Madhu, can you do that immediately?
Yeah, yes, thank you. Because this is, thank you. So these are, in US, for example, the International Code Council or ICC certifies there are several companies, a handful of companies, including us, that our products have been tested and approved by them and certified for such applications. I want to really caution you here that I know I have heard that there are companies in like some of the designs, apparently some of the in India, for some of the projects, the engineers are saying, well, just use a carbon fabric and epoxy. And you have to be very careful that this is a recipe for disaster. These systems that I'm showing you here, they have been tested for decades and proven that they work in combination, they work together well. So you must make sure that, again, this gentleman, whoever it is it's just like running this show, and I don't know why. Could you, Mr. Ravindra, could you ask them please not to touch anything so I can?
Yeah, we are figuring out who's doing that, and we'll lock him out.
But what is his name coming?
I don't know. Yeah, someone is doing something.
Uska naam kya hai? What is his name? Annotations have been stopped.
I don't know who's doing that. Can you figure out, please?
Madhu, you take over full charge. Remove all admin rights and keep them with you only.
Yeah.
Thank you. Yes.
No, please, Mr. Mo, please continue. Mr. Mo, please continue.
So here is an application, for example, to some girders of a bridge where a truck oftentimes hits them and damages them. And as you can see, these repairs can be done easily, for example, at nighttime when the traffic is low and you can accomplish maybe 2 or 3 nights. You can, like here we are doing in a project in Phoenix, we can repair 2 or 3 in 2 or 3 nights a lot of these girders without disruption of traffic. So we can strengthen them for shear or for flexure this way. Of course, if the concrete is cracked, it may require some crack injection. So here, for example, we are doing first the crack injection in the concrete, and then realizing that that crack was formed because of lack of steel, then following the crack injection, we could apply the carbon fabric to provide additional strength for those beams that were weak. This is another application. For example, in this case, this was a hospital that they wanted to add a heavy MRI machine on the 3rd floor of the hospital, and we ended up, strengthening the floor by putting these carbon strips inside of embedding them in the floor. This entire repair, for example, took only about a day and a half, and without bringing any steel from under the slab to strengthen it, everything was done from above the slab on the floor. And as you can again appreciate that the amount of time in a hospital like this, for example, how these things matter, that you can be achieved quickly. I wanted to say a little bit about these columns. The issue with a lot of these columns is that, especially in seismic regions, where the older codes, they require to provide a tie at a spacing of 300 millimeter along the height of the column. And also these ties had a poor detail on, that overlapped on the edges. So during an earthquake, for example, the ties would open up and the bars would buckle. As you see here, you get collapse of the columns, tied columns, but for spiral columns, they perform pretty well. So the solution to this is to provide confinement around the column, and that confinement can be done when you provide that confinement. Not only you increase the strength of the concrete, but you also improve its ductility. So here, for example, you go to about 1% failure, whereas the unconfined concrete only a much smaller failure strain at failure. And in places like California, they have been using steel jacket to provide that confinement, but these are very time consuming and heavy to handle on the side.
If you're doing the same thing with these composite materials, if you're only
I don't know what there's that one. So here it just shows you that how with those composite materials we can apply these. And I just want to also draw your attention that, so if you have a very badly corroded system like shown here, you first have to repair that concrete, make it smooth, and then apply the fabric. This is one of my latest inventions, sidesteps this whole issue. So that's one of the advantages of that PileMedic system, is that you can directly apply it without spending time to repair the surface of the concrete first. And here are some other applications, applied to like seismic upgrade of bridges in California, that they are being wrapped around those columns. So again, another bridge case where there is badly corroded, we fix it, bring it to the original shape, and then the fabric is wrapped around in bands of like 1.2 meter bands. It is wrapped continuously around. And keep in mind that not only we are strengthening this, but now this entire column is encased in an impervious shell, so the service life of it is tremendously, enhanced. As I mentioned, one of the things we have developed, is this PileMedic, which are these thin laminates that we manufacture, and they make a lot of these column repairs much easier. And I hope this video shows that you can see how we can repair columns in water, for example, for ports and piers. So the laminate is cut in the field to the length that you need. This particular epoxy that is applied to it, it cures underwater, so you don't need any coffer dams. And you see here, They wrap that around the column, but the surface of the column could be rough. It doesn't need to be finished before. We create this jacket around the column, and then the annular space is filled with grout or concrete. And so very quickly, these columns are fixed. This is a product that has been tested by the US Army Corps of Engineers, and it's now the only product that the military uses worldwide. Here are the military, Navy, and military personnel developing, training in Hawaii. And you see these sheets are taken into the water, wrapped around the pile, and they were testing different water conditions, visibility, wind, and speed of water, and
versatility as a one-size-fits-all pile repair system. Repairs using Pyometic were also accessed in a variety of conditions, including darkness, rain, high winds, and rough waters. Pyometic thanks the U.S. Transportation Command.
So these are, this is
and the U.S. Army Corps of Engineers for the live footage of these repairs. Visit Pyometic.com.
So these things were later on, we have used them in Pearl Harbor actually to repair about 90 piles, and now we sell these kits to the U.S. military. They were doing some projects right now they're doing in Ukraine using these as we speak. This technique or this product that we have developed also for the first time allows you to use FRP to repair steel columns. Because if you have a steel column here, in fact, this is so badly deteriorated, there is only paint is holding this steel column together in a mine. And with these, of course, you cannot apply the FRP to the surface of these, but we can, with this new system, we can create a shell around that that can be filled with concrete. We can insert some reinforcing bars if needed. So these types of failures, they can be fixed without taking the structure out of service. And we have used these also on over 100 cell phone towers that are strengthened in places like San Francisco and Los Angeles to add additional capacity for the cell phone companies to put more equipment on them. The last thing I wanted to show is that how we use this I-beam concept of using a sandwich construction. So carbon FRP is not that inexpensive. So if you want to put many layers on top of each other, it becomes pretty pricey. With this system, if you put something in between and separate them, then you can see that you get just like an I-beam. Here we have, for example, 2 layers of carbon put together. But if I spread them by putting some less costly material in between, I can get much higher stiffness with relatively little additional cost. And so we use this for some of the products that we can make these rigid elements for repair of seawalls or even ports and piers or under the bridges and so on. This is one such application. In this case, this is a seawall along here, which is badly corroded. This plant is a pulp and paper plant. So the soil had some chemicals in it, and they were worried about this chemicals leaching into the water. So we make these panels in our facility using also some FRP rebar. Then on the job site, these panels are connected with J-bolts in front of the old deteriorated wall to create a new wall that is impervious and becomes the stay-in-place form. So then once this wall is in place, then we can fill the annular space behind it with grout. And you notice that in such repairs, even when you have very limited space, these panels are light enough that the divers can take them under these fenders and install them. And here you can see them working, putting the panels together. And finally, after the grouting operation has been completed. My just last thing to show you, this same system, we can make them in different shapes. This is a project for the Port of Galveston in Texas that we just designed. And as you can see, when you have a shape like beam like this that is so badly corroded, especially when you have little headroom under, above the water, it is very difficult to repair all of these. But once you chip away at the deteriorated shape, we custom make these panels that they are brought in place, lifted in place, and they get bolted to the underside of the structure like these, and then they are filled with grout or concrete. So these make the repairs much faster and economical, but more importantly, these forms stay in place and they provide an impervious protective layer for the newly placed concrete. And that way they extend the service life of these structures significantly. I know because of the time limitation, I'm going to stop now, but I wanted to draw your attention that in the beginning of COVID, we gave some webinars to an international audience. One of them, and those webinars are available on these websites. You can download them. Each of them are about a little bit over an hour long, but they're a video you can watch at your own leisure. So one of them, the first one, is about repair of piles and marine infrastructure, seawalls and piles and piers. This is the address for that website. The other one is for the repair of all kinds of pipes that I didn't get to really cover much today. And this webinar talks about all of our various solutions for pipes. So this, as I said, this was just a quick introduction today. Hopefully you can follow this through. If you like videos, we have a YouTube channel, the address here in red. This is our YouTube channel. We have over 130 videos of different projects, and you can always watch and see how these products are being used. So with that, I think I'm almost within my 30 minutes of allotted time, but I'd be happy to answer any questions that you may have.
Many thanks, Dr. Mo, Ehsani, for the excellent presentation. And I should put the words like this. This is down-to-earth presentation so that everybody could understand what is the concept about. Not into very complicated issues.
Sir, what will be the... Sir, I want one question. I want one question.
Sir, now we'll be having a question answer session now, sir.
Yeah. President of Builders of India want to ask a question.
Yeah. Now I request Professor Ravi Sinha, who is the Dean from IIT Mumbai and who is a professor in Civil Engineering Department, and Dr. Rajiv Gupta, who is also from Civil Engineering from BITS Pilani, to take over for the question answer session.
Okay, great.
Mr. Rajiv Gupta, you can unmute yourself. You are the co-host. Mr. Ravi Sinha, I think he is not there. Mr. Ravi Ringsha? Ringsha, sir?
I think we can start with Mr. Rajiv Gupta now.
Yeah.
Okay. Thank you, Mr. Chandrakant. And now floor is open for the question answers. And I think if I'm allowed, not many questions are there, but everybody is saying that excellent presentation. One or two questions are there in the sense is this material protruded? Can we protrude this material?
I'm sorry, what can we do with them?
Can the material be protruded?
Protruded. Yeah.
Protruded. I'm not sure if I...
The material is available only.
Oh, I see. In India, I know that you have some, apparently there are some, from what I hear, there are some fabric manufacturers and some resin manufacturers. But again, I want to caution you, you can go buy to your local, home supply or hardware store and buy epoxy, but that doesn't mean that you can achieve these solutions that I'm talking about with those products. Make sure that whatever products that you're using has been tested, and both in terms of a short-term application and in terms of also durability. But we are also, we have some affiliates in India, and we are looking at manufacturing some of our products soon in India for the Indian market. Because there are, for example, there are some ports already in India that we are in discussions with them, and they can, they're interested in using these to repair some piles underwater in those facilities.
Thank you, sir, for to the point answer, sir. And another question is barnacle resistance? These particular FRPs are barnacle resistance?
Barnacle, they are not. No, they don't resist them. Barnacles attach themselves to the exterior of these, but again, they will not because there is really nothing for them to feed off of this. So they are aesthetically going to be present there, but they don't really cause any damage to their structure. But they can attach themselves to the outside of these. Yes.
I have a question.
Yes.
If I may say.
Yeah, please go ahead, Mr.
Yeah, I'm Professor Dr. Sundaram.
Yeah, Sundaram.
My question specifically addresses, you have addressed corrosion resistance with the help of your fabric. I want to know if marine creatures and microorganisms will not damage the covering which you are putting. So I want to know if the fabric has been treated for barnacle resistance, specifically for marine objects, and if it can also go into other type of structures. So I want to know what care you have taken to make sure that microorganisms don't deteriorate the structure.
We have not.
It will happen over a period of time.
Yes, we have not really looked at that aspect of these microorganisms. We have not looked at that. No, okay. but for corrosion, typical corrosion, we have looked at.
Okay, so there exists scope for research in that area then?
Oh, absolutely. There is a lot of research. If anybody is interested, contact me and I will give you a long list of projects to work on.
Sure. Thank you. So nice.
Yes, and a few more questions are coming up. People are showing a lot of interest. I am integrating few questions. One is that are they monolithic with concrete? What is the cost? And where is your office in India?
Our office in India is actually, if you go to QuakeWrap.com and look at the contact page, you will get the full information and email and phone number, everything about our office in India, Australia, and US. So I refer you to that. These materials, if they are, so when we bond them, for example, when we use the fabric and we bond them, if you use the right type of adhesive, like what we have done, then they do behave monolithically with the concrete, once they have been bonded to it. And again, I want to really emphasize that, like what type of epoxy you use and whether it has been, tested to show that it works with that system is very critical. But given the right products, then yes, they do work monolithically with the concrete structure.
Excellent. Just a few more questions I will take because we have limited.
Two persons have raised their hands. Dr. Ganesh Hegde from Goa and one Mr. Pratik Rai.
Okay. So, Mr.
The cost, I think, I'm sorry, but I think they had something about the cost of these materials.
Yes.
These I can give you the numbers in US, typical carbon fabric is about, in US, they sell for about anywhere from, depending on the weight and density of them, anywhere from around $50 to $70, $80 a square meter, roughly. And then the resins are roughly, I would say maybe about $15 a liter or so. So it is, it is a little bit pricey, but in US, all of these projects that you see that I was showing you, the main reason we did these projects was the low cost and the long service life of the solution. So they are very economical. Now in India, because of the additional, the government imposed tariffs and taxes for importation, it becomes really expensive to import these to India. And that's why we are looking at manufacturing some of these in India. So hopefully within the next 6 months, a lot of these products of ours, we'll be able to offer them in India and made in India actually for that market.
So do you really recommend this for general construction?
I think, I should tell you that one of the problems with FRP products is that in general, they have much lower modulus of elasticity compared to steel, for example. So I would say that in most cases, they don't become very economical in most cases for new construction. But when it comes to repair and strengthening, like we are using here, then they become really economical and they can beat a lot of other conventional, repair systems.
Okay, just Dr. Ganesh Hegde from Goa. Please put your question in brief, sir.
Yes, sir. Yes, sir. Thank you. Very nice presentation. Very nice information. From the information which I have seen, FRP is being used when the structure get damaged, maybe for the lifeline structures like bridges below the water level and sea walls. Why can't we make this as a compulsory, a layer on the fresh structure itself, so that this damages, corrosions can be extended? Whether it is not possible to do that.
It is. Unfortunately, the mentality of engineers and building facility owners, people really, they don't have that frame of mind that if you pay a little bit more, of course, it would cost a little bit more, but it would be much longer lasting. Unfortunately, the way construction bidding works, everybody wants to go with the cheapest solution. But there are in some cases, for example, we don't make them, but there are companies that make, for example, FRP tubes as stay-in-place forms that you could use them and pour your concrete in them. So for like marine construction, you could use those. As long as the building owners are willing to pay a little bit extra, to go with those systems.
Yeah, as long as structure is lifeline, we should go for such type of and confinement before structure start deteriorating. We can extend the life.
Exactly. Yes.
Thank you. Thank you.
Yeah. Thank you. I invite Mr. James to ask the question, but before that, is it highly inflammable, flammable? That is a kind of question.
No, actually, yeah, no. So let me say a few words about fire resistance of these products. Yes. So what happens with FRP products in general is that when they get heated and when they reach a temperature of about, if you don't do any special treatment, they are good for all kinds of ambient temperature. I mean, we have done a lot of projects in Saudi Arabia, for example, where it gets really hot. That's not an issue. But when the ambient temperature reaches about, so like if you have a temperature of about 80 degrees centigrade, which is not much, the resin starts to become soft. And not the fibers. The fibers can take very high temperature, but the resin becomes soft. So for that reason, if there is a potential for fire, then there are fire coatings that can be applied on top of this, just like you do with steel buildings, that you apply a fire coating on top of them. And then the other thing to keep in mind is that the damage to these, because they don't transmit heat so much, the damage would be concentrated locally. So even if it is, you might get a little bit of a patch of it that gets damaged. That area can be cut out later on after the fire and repaired if needed.
Okay, Mr. Van, are you ready with your question? Do you want to ask the question, Mr. James? If you have finished your chips?
I don't think so, sir.
Okay. So I don't think any other question. I think
I have another question, sir. What about electrical property? Hello, can I ask a question quickly, please?
Okay, please quickly we can ask.
Yes.
Okay.
What about electrical insulation and capacitive properties of this material?
Oh, they're excellent for, in fact, especially if you use glass fiber reinforced polymer, GFRP, they're excellent, for, they don't conduct any electricity. So you can, those are some great applications of those. And we use those for some of our electrical utility clients for
has this been tested by C requirements or FCC and
not, I'm sure, I mean, we have not tested those, but I'm sure that they are used extensively in that industry. So I'm sure.
You are mute, Dr. Mo.
So Dr. Mo, sir, unmute yourself, please.
Me. Okay.
We can't hear you.
Yeah, I was saying that we have not done those tests ourselves, but I'm sure the tests like that are done by others, manufacturers that supply to the electrical power industry, for example. And they are, I know that especially glass FRP is excellent. It doesn't, conduct, it's a good resistor to electrical current.
Okay, so
Thank you
a lot, sir. And for all the members who participated, such an interesting topic. I know all the questions cannot be completed and discussions can go on. So I really thank Dr. Mo for such a nice answering most of the questions, all the questions. And I ask all other participants, if they have any particular question, they can please email to Dr. Mo with his permission. Thank you very much, sir.
Thank you so much. I appreciate it. Have a great evening. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Thank you all.
Yeah, I close this session here.
Many thanks, Professor Rajiv Gupta ji, for conducting this session in a very excellent manner and giving time to all the participants for the questions also. And special thanks to Dr. Mo for patient answering number of questions. Now is the time for concluding remark to be made by none other than Mr. Rajendra Pawar, who is the former Secretary of Water Resource Department, Government of Maharashtra. I request Dr. Rajendra Pawar to kindly take over.
Thank you, Chandrakant-ji. Am I audible to all?
Yes.
Yes, thank you. At the outset, I must congratulate Dr. Mo Ehsani for his very simplified presentation on such an important topic, so that we could be able to easily understand what the technique is. Basically, you are having very vast construction industry, even in India also here. Not only for buildings, but many huge structures like bridges, flyovers were built. And if there is some fault, maybe due to workmanship or maybe some kind of failures like corrosion and many other effects are there. So there was not actually a perfect solution for that. It's a kind of disaster. So I think your technique has come as a rescue for such structures for disaster mitigation in future. And really, it's a kind of help for the construction industry as a support system. About the presentation, he has very nicely narrated all the different techniques used. What I gather from his presentation is basically it's an effort to enhance the tensile strength of the components which are weakened by the maybe corroded reinforcements and many other causes. The different techniques like some FRP sheets, fiber sheets, which he has widely used. Some kind of crack injections methods are also there. Confinement solutions for structures like columns and other things. Some sandwich construction concept he has told us. Stain placed forms. So all these different methods can be really easily used. And it's a really amazing technology which he has invented and working since last 30-40 years in this. I think as like automobile industry, which is having a backup support of like garages or maybe
some after sales service. So similarly for construction industry, this kind of a system as like repair house or repair centers, which will be with systematized approach for any solution for this repair work according to the requirement, with the technical support and with designs, all the test procedures, and of course accessible to each and every constructor. That will certainly help and support the construction industry. Along with FRP, which he has shown us, many numerous other materials can also be used, maybe like say ferrocement or other kinds of resins or materials for this basically retrofitting works. So at the outset, I once again congratulate and thank him for the excellent introduction of this new material and as well as technology. And thanks the SC for giving me this opportunity to give my concluding remarks. Thank you. Over to Chandrakant.
Thank you. I appreciate it. Thank you so much.
Many thanks, Rajendra Pawarji, for summarizing the things and about the discussion. Now is the time for vote of thanks, which has to be given by our own Mr. Anand Gupta ji. Mr. Anand Gupta ji is presently the chairman of Housing and RERA Committee of Builder Section of India, and he has been associated with construction industry for more than 40 years. He is the chairman and managing director of AYG Realty Private Limited and AYG Edifices Private Limited. He has a number of prestigious buildings and infrastructure projects, mass townships for private institutions. He has been working for MES, CPWD and state government projects. And presently, he is into real estate development project in Pune, Kalyan, Dombivli Corporation and Raigad district. He is the spokesperson of Builder Section of India and is the past General Secretary of Builder Section of India. Over to Dr. Anand Gupta, please.
Good evening, friends. I hope you all can hear me.
Yes.
Yeah, friends, after this excellent presentation, I have been given this present task of proposing a vote of thanks. So first, I would like to thank our chief guest of our today's function, our own president, R.N. Gupta ji, for sparing his time and giving us a good word of advice as an inaugural session. Second, I would like to thank our expert speaker, Dr. Ehsani from USA, who has given his all expert opinion how to repair all the housing and the infrastructure structures and the status of the today's modern technology to repair these all structures. Thank you, sir, for taking all the pain and getting such an early morning for all our guests in India. And we are really thankful to you. I would also like to thank the board of American Society of Civil Engineers. I also would like to thank all the office bearers of BI. I also would like to thank Indian chapter of American Society for taking this initiative and organizing this valuable webinar. At this juncture, I also would like to thank Dr. Kamal Lokashri from Sri Lanka, who is a regional director for American Society of Civil Engineers. I also would like to thank Dr. Ilyas from UAE. I also would like to thank Dr. Tom SK, Professor, Purdue University, USA. I hope I'm pronouncing his name properly. I also would like to thank Mr. Carlo from Mexico. I also would like to thank our own Sunil Joshi ji from Canada. I also would like to thank Mr. Tilak Raj Kapoor, Mr. Ramchandani for their valuable presence. At this juncture, I also would like to thank Mr. Rajendra Pawar, past secretary from Government of Maharashtra, for taking all the pain and giving his expert opinion and making a concluding remark on the whole presentation. I also would like to thank our own Chandrakant Rajpatji for doing a valuable work of Master of Ceremony. I really thank him for excellently conducting this whole session. I also would like to thank Mr. Lokesh Kumar, Mr. Rajiv Gupta for conducting question answer session. I also would like to thank Mr. Sunny Sukekar, who introduced our expert speaker. I also would like to thank our own Mr. Mohinder Rijwani, Chairperson, Mumbai Chapter of Builders of India, for introducing our chief guest. And the friends, I also would like to thank Mr. Engineer Ravindra Ringashia, President, American Society of Civil Engineers of Indian section of Western region, for taking all the initiative to invite our expert speaker and collaborating Builders of India and all the American Society of Civil Engineers and Indian chapter of American Concrete Institute for taking all the initiative. I'm really thankful to him, and I hope to see continued support from him. I also would like to thank our own Head of Communication, Builders of India, Mr. Madhusudan, for taking all the lead for making this program successful, publicizing it properly, and making the grand success of this webinar. Friends, before I conclude, I also would like to thank all the participants. More than 220 participants participated, and without that, this webinar would not have been much of use. And I'm sure they have taken a very valuable message and very valuable learning. And I hope to see their continued support for our incoming programs. Thank you all.
I take the opportunity to thank Dr. Anand Gupta ji also for his lovely assistance and guidance for the success of this program. Thank you, Anand ji.
Thank you.
Thank you all.
Thank you. And
now I think we can disconnect.
Yes.
Have a great evening. Take care.
Thanks, Dr.
I think now we can conclude we can close
Yes, Mr. Sunny, if you are there, we have to look into that thing. Somebody was annotating it. We have yesterday worked on it, but still, I think next time we'll do the homework.
Sure. We just.
Sorry, Mr. Mo.
Yeah. I don't know who was pushing
Yesterday we had a meeting. We did our homework, but anyway, let's see.
No, that's okay. Yeah.
We'll go through the recording and see who was doing that.
Yeah. Thank you so much, really, for organizing this. I
Thank you, Mr.
it was
Mo.
nice meeting you. Hopefully, I will meet you in person soon, one of these days.
Sure.
Our pleasure.
Welcome, Mr. Mo.
Dr. Mo,
Thank you, sir.
Good morning to Mr. Mo. Have a nice day. Have a nice day. Your day is
Have a nice day, sir.
Your day is getting over.
Thank you.
Okay.
Thank you. रविंद्र जी क्या समझ में नहीं आता कल अपन किया सब कुछ रायपत जी बाय टाटा
चलो बाय
Bye guys.
चलिए बाद में